All right. This is Case Connections Unit 2 assignment. There it is, Thomas Paulson. It is January 13th, 2022, and I'll just get right into it. So I did Case 1 and Case 2. So starting with Case 1, we're asked, what are all the ways that pyruvate kinase are regulated within the cell? And I was able to find many different ways in which it is regulated. So I will go over those. So first starting with FBP, fructose bisphosphate, which is the phosphorylated version of fructose 6-phosphate. And this can allosterically activate pyruvate kinase. So, it will push it closer to its transition state and allow it to be more active. Another example here is both epinephrine and glucagon. They are used to deactivate pyruvate kinase, and they do this specifically through covalent modifications, which is different than being allosterically activated. They're either cleaving or adding functional groups covalently to pyruvate kinase, which we can see here is in both epinephrine and glucagon, it's going to have a deactivating effect on PK. Another one here is cyclic AMP, and this will inhibit the activity of pyruvate kinase through hormonal action. So again, kind of a different means by which this modification or how pyruvate kinase is regulated. Here, it's through a hormonal pathway via cyclic AMP. I think I have three more here. Another one being the phosphotyrosine, or when it signals, it's known to reduce the activity of pyruvate kinase. Additionally, oxidation of C358 by an ROS will reduce PK activity. And lastly, in unfavorable conditions for pyruvate kinase type M2, acetylation of K3O5 causes it to have a low affinity for pyruvate kinase type M2 towards PEP, and degradation follows. So yet again, another way in which it's regulated, and that last one actually feeds kind of into the next prompt. But before going there, as we can see, most of these actually have a deactivating or a slowing down effect on the action or activity that the pyruvate kinase likes to engage in. So on to the next part of the prompt in Case 1. We're talking about cancer, or cancer metabolism inside of a cell. So it asks us, in cancer cells, pyruvate kinase M2 is more expressed than M1. M2 has a lower activity state and is less effective in promoting glycolysis than M1 or type L. Right? It seems counterintuitive. So what is the rationale here? And how is cancer trying to overcome this? Right? So basically, trying to put it as simply as I can, we know that pyruvate kinase type M2 is important in self-renewing cells like stem cells, right? And we knew that even from just the prompt above in the very first part of the question. So that right off the bat should tell us that it's going to be involved in cancer metabolism, as this is trying to proliferate new cancer cells. So most cancer cells have shown increased expression of pyruvate kinase type M2. So they're very important in cancer metabolism. In cancer metabolism, the transcription factor MYC causes more expression of PKM2 through RNA splicing. This is done indirectly, as MYC splices for different factors. However, those factors tend to favor the production of PKM2. and as opposed to type 1, right? And this is good for us because PKM2 is detectable and does much to slow down cancer proliferation, right? It's not as good at, allowing new cells to grow, like PKM1 is. Obviously cancer is a big issue, and it will continue to try to grow, in different tissues and in different avenues, but this was very interesting to learn about, and it's cool that PKM2, whether cancer likes it or not, is going to play a role in kind of our body's defense mechanism against cancer cells. So this was really cool to learn about, thanks to pyruvate kinase type M2. So that's it for case 1. For case 2, this one seemed a little more straightforward actually, but basically we're dealing with a 16-year-old female who is diagnosed with the deficiency of muscle glycogen phosphorylase. Her and her family are concerned and asked the following questions based on what I know, and these are the answers based on what I know about skeletal muscle glycogenolysis and muscle metabolism. The whole goal is to respond here kind of like I'm a doctor, or like I'm the one that's in the know as it comes to these questions. So for starters, this girl asks, I'm not sure I understand the issue. Can you explain how muscle glycogen is used normally during exercise, right? So basically you're the girl, and I'm the person explaining. So I say, our muscles have something in them called glycogen that is potential fuel for utilization and movement. Before we can use the fuel, it needs to be modified a little bit. When needed, glycogen is turned into glucose 6-phosphate, and that is glycogen phosphorylase's job. When done properly, glucose 6-phosphate is made, and that's the fuel that our muscles can use while exercising. So as you can see, the lack of glycogen phosphorylase is pretty detrimental to the production of glucose 6-phosphate. Question 2, she says, I really like to take long walks. Will I still be able to do this with my friends? To which I say, for someone with your condition, they're going to be challenges with any type of exercise, as you'll be more prone to experiencing pain, stiffness, and fatigue in your muscles, due to the lack of fuel. Because there is simply less of that produced by your body, as glycogen phosphorylase has difficulty making as much usable fuel as it does in other people, which we call glucose 6-phosphate. It's definitely unfair. However, studies have shown that people with this condition can and still should exercise. The key here is to just avoid activity that is too strenuous, because it would put too much strain or too much stress on your muscles, and could lead to other problems. However, your body is not unable to create this fuel. It can still do it, just at a lower clip. So yes, going on walks is encouraged, I think, in this scenario, but it might not be super comfortable. As a result of this deficiency, will I need to get up, this is number 3, right? As a result of this deficiency, will I need to get up at night to eat to maintain my blood glucose levels, right? To which I say, nope. Just make sure you're being vigilant that you're getting enough carbohydrates throughout the day. During the night will actually be a great time for your body to produce the usable fuel that it can. So for anybody with this condition, I think it's wise for them to take advantage of as much sleep as possible, manage their diet, and give their body a chance to rest and digest and make as much usable fuel as it possibly can, so that you're at less of a disadvantage. All right, and then the last question is, do I need to worry about producing excessive lactate during intense anaerobic exercise? So this is kind of the funny part about this condition, the lack of glycogen phosphorylase, is the way that it's located or how it works in the glycogenolytic cycle, it's in such a position that it's not going to increase the levels of lactate either before or during or after exercise. So those levels will stay relatively the same. So someone with this condition wouldn't need to worry about producing excessive lactate, which I guess could be seen as kind of an advantage. But obviously having this is, there are many more disadvantages. So the type of pain that is felt or discomfort is likely not going to come from, lactate like most other people would feel after strenuous exercise, but probably more on the side of your muscles are starving, and they and just the added strain would be where that discomfort comes from. But that is it for case connections number 2.